Alright, now that we've got all our angles down in circles, we're going to switch back gears a little bit into segments in circles. We've talked about them. We've talked about chords and secants and tangents. We're actually going to use some theorems so that we can find the lengths of some of them. So we want to identify the three product theorems for finding segments in a circle. So we're going to talk about three things. We're going to do one theorem, do some problems, one theorem, do some more, and then your last theorem. So first one, if two chords intersect in a circle, then the product of their pieces are equal. In other words, if we had AE, EC, BE, and DE, if we had all these, let's go ahead and just label them X, Y, A, and C. Doesn't really matter. What we would say is that X times Y is equal to A times C. And that's it. So the two products are equal to each other. So let's try some. TR is 6. TG, the whole thing, is 10. IR is 3. Find RE. Okay. Well, if the whole thing, TG, is 10, and part of it's 6, then this part's going to be 4. So all we're going to do here is 3 times X equals 6 times 4, and solve. So X equals 8, so we would properly label this as RE is 8, and I'll go ahead and call it just units. Next one, ZB, the whole thing is 12, and I do put it out here for a reason so you don't get confused with maybe ZA or AB being 12. So ZB is 12, RA is 16, AE is 2, find ZA and AB. Now, we can't label it X and Y because you guys know we're going to get stuck. So if ZA is 12, or I'm sorry, if ZA is X and the whole thing is 12, to label AB we would say 12 minus X. We've done this before. Now some of you might be thinking, would it matter if I had AB as X and ZA as 12 minus X? No, it would not matter how you did it there. Okay. So let's go ahead and see what we come up with. And we have 2 times 16 equals X times 12 minus X. You guys probably are going to see what's going to happen. 32 equals 12X minus X squared. Since that's a negative X squared, I'm actually going to move everything to the left side so I don't have to deal with that later on. So I'm going to have positive X squared minus 12X minus 32 equals 0. So I'm going to have X minus some number, X plus some number equals 0. I know it's going to be a negative and a positive because it's a negative product. So if you're thinking here, what might work? Well, you could try 16 and 4. Whoops, whoops, whoops. That should be a positive 32. Otherwise, we're never going to get anything. So it needs to be two negatives, actually. That 32 stayed on the left. Shouldn't be a negative. So we need two negatives. Negative 8, negative 4 works. So you get X equals 8 as one answer, X equals 4 as your other answer. Do they both work? Well, let's see. Plug in 4, 12 minus 4 is 8, good. Plug in 8, 12 minus 8 is 4, good. Okay. So what we're going to see here is that both of those answers work. So you can plug in, and you're going to find that it doesn't matter. So if you plug in 4 here, 12 minus 4, you get 8. And if you plug in here, 12 minus 4, I'm sorry, if you plug in just 4, you'd have that. Now, this is where it goes back to looking at the actual problem. You probably want to say that you're going to use that 4 over here, I'm sorry, the 8 over here and do 12 minus 8 and get 4 and let this be 8 over here. Okay, so your 4 and 8's what work, but it makes sense if that longer piece is 8. So we'd say ZA is 8, AB is 4. Okay, just by the way it works there when you plug it back in, it makes more sense to say the longer piece is 8 and the smaller piece is 4 there. Last one. R is a midpoint of TG. So that means that this is congruent to this. That's important. It's telling us something. IR is 4. EI, the whole thing is 20, which means this is 16. Find TR. Okay. Now this one, if they're both the same, it's a midpoint here, we can do this is X, and so is that, because they have to be equal. It wouldn't be X and Y because they're the same. So now we're just going to go ahead and do 4 times 20 equals X times X, so 80 equals X squared. We always assume exact answers. You'll find that the square root of 80 doesn't work out. We can break it up into an 8 and a 10, 2 and a 4, break that up. So we have, let's see, a pair of 2's there, pair of 2's there, 5 alone. So 2 comes out, another 2 comes out, a 5 stays inside, so our answer would be TR is equal to 4 radical 5. So again, maybe some labeling issues in here, but you're just, again, doing one piece times one piece equals the other piece times the other piece. Okay, so the product theorem for the two chords. Your secant-secant product theorem. So this kind of looks like the angles where we had those arcs that were being intercepted. If two secants intersect outside of a circle, then the product of the lengths of one secant segment and its outside piece equals the product of the other secant segment and its outside piece. What I mean by that is you have, this is the whole, and then you have this is the outside. And same thing on the bottom. You have the outside and then you have the entire thing. And our theorem is that the whole secant times the outside equals the whole secant times the outside. Okay, and you will use the inside in certain parts to find outside and the whole and all that. So it's whole times outside equals whole times outside. Or I like to say whoa equals whoa. You can do the thing with your mouth where people do WOW or whatever you guys used to do. You probably don't know what I'm talking about. Vertex outside, so we're going to do whoa equals whoa. So the whole of the top one would be 10 times the outside would be 2. The whole of the bottom one we would label as x plus 4 times the outside is 4. So whoa equals whoa. 20 equals 4x plus 16, distribute in. Subtract 16. 4 equals 4x, so x is equal to 1. Okay? So that would be your x there. So whoa equals whoa. Alright, next one. We have whoa equals whoa. So we're going to say the whole of the top is 10. The outside of the top, that's easy, is 5. Equals the bottom whole is x plus 23. 23, not 32. Because again, we would label that as x plus 23 times the outside is x. So you have 50 equals distribute in. We have x squared plus 23x. You guys know what we're going to have to do. So 0 equals x squared plus 23x minus 50 to get it over to that side. So 0 equals x. We have some x's. We know it's got to be a positive and negative because it's a negative product. 25 and negative 2 will do. That'll work. So 0 equals x plus 25. 0 equals x minus 2. So I'm showing all my work this time. So negative 25 and positive 2. Negative 25 cannot be that length outside there, so you're only going to keep positive 2. Last one of these. Again, we have whoa equals whoa. So we have the whole outside is x. I'm sorry, the whole is x, so that the inside is 9, so we would label the outside as x minus 9. So we have x times x minus 9. Whole is x, outside is x minus 9, equals the whole of the bottom is 9 times outside is 4. x squared minus 9x equals 36. And again, we do need to factor. Good thing you guys are experts. And let's see what'll work here. X minus 12 and x plus 3. So x equals 12, x equals negative 3. Just double check which ones work, which ones don't. Well, 12 is the only one that works because negative 3 cannot be a length there. So that's your secant product theorem. So WO equals WO. Secant tangent product theorem. This is the last one. And it says if a secant and a tangent intersect outside a circle, so the tangent is the one where it just touches, like right at that point A there, then the product of the lengths of the secant segment and its outside segment equals the length of the tangent segment squared. So this one, what that's saying is WO equals the tangent squared. Okay, so whole times outside equals tangent squared. So we're going to get some practice with this. So number 6, we have the secant. We know we're going to label that secant, the whole thing, as x plus 2. And what it says is we have WO equals your tangent squared. So whole is x plus 2 times outside is 2 equals 6 squared. So we have 2x plus 4 equals 36. 2x equals 32. X equals 16. In number 7, that's a secant and a tangent, so WO equals tangent squared. You're going to be saying WO all day tomorrow. So we have whole, the bottom, that's our secant, is 25, times the outside would be 4, equals x squared, tangent squared, so 100 equals x squared. Take the square root. Technically it would be positive or negative 10. We would just keep the positive 10 because it has to be positive. And the last one. Turned a little bit, doesn't matter. We still have WO equals tangent squared. So the whole, again, you guys are pretty good at labeling things like this, is x plus 12. So you have x plus 12 times outside equals 8 squared. So that's going to be x squared plus 12x equals 64. So x squared plus 12x minus 64 equals 0. Let's go ahead and continue this up here. I guess I'll just rewrite it. That'll be the easiest. X squared plus 12x minus 64 equals 0. What works? And you could do positive 16. Maybe you beat me to it. And negative 4. So we have x equals negative 16. X equals 4. Not showing my work for that, getting to that part because I'm an expert at it. Most of you guys are too. X equals negative 16 does not work. X equals 4. Good to go. We can have that outside there. So again, WO equals WO for your secant, and then WO equals tangent squared for your secant.
So with all this talk of whoa, I wanted to show you guys a little Ric Flair versus Joey Lawrence